Hello, my name is Gal Messinger, and I'm the owner of Solar Messenger. I'm also a professor that teaches environmental studies, and I'm very much into the environment for many, many years. I would like to share with you this short lecture about solar system optimization. And I hope you already watched the first part, Solar Systems 1-on-1, because some of the material there is necessary. So without any further ado, I'm going to just share these lectures with you, lecture notes. So if we talk about a solar system, it's not a very straightforward um, process, mainly because a lot of information is involved in designing a solar system, which is a lot of people don't know it because they just buy something. It's the same as you buy a car, and that's it. But other people are more interested to know what goes into the process. So if you're one of those people, this video definitely is going to be interesting for you. So first we have to understand a few very basic terms. So people talk about voltage, current, and power. And unless you studied it in physics or electronics, it's not that easy because you cannot really see, smell, or touch, hopefully not touch electricity and understand what's going on. So basically voltage is like pressure. It's like your pressure in a pipe. And the current is the flow. So if you want to fill up a bathtub, you need to take into consideration both the current and the pressure. The higher the current or the higher the pressure, the more power you have. By the way, power is not energy. Energy is the stored power. So the power is basically if you have a light bulb of 100 watts, that's power. If you cycle and if you've got an e-bike, it's even more obvious. You're going to cycle about 100 to 200 watts, which is like you can operate one or two of those light bulbs that are not talking about your LED light bulbs like the regular ones. So in North America, which Canada is part of, we've got a service of 240 volts, which is a split phase. So we have 120 and 120, and it's split around the house. Basically, if you look at your breaker system, you'll see that you have two sets of breakers. It's hard to see, but one of them is connected to one split phase and the other one to the other half of the phase, which means each house theoretically can consume 48 kilowatts of power because the flow of the current, as we said, times the voltage, the pressure, gives you 48,000 watts or 48 kilowatts. Now, we usually don't do this. Usually the house consumes much less. Now, what is energy? Energy is that times the hours that you use. So power is the ability to work. So if you ride an e-bike and you push your pedals modestly, probably produce 100 watts of power in your legs, a bit more fiercely, 125, 150. But if you put it on a simple cruise and then you just hit the first level, in my e-bike is 125, you can sense that e-bike is basically giving the same power as you do. But what is the energy? The energy is the stored power. If you have a battery for this e-bike, that is the stored energy. It also has the unit of watts, but times hours, watt hour or kilowatt hour. For instance, a kilowatt hour, 1 kilowatt hour can operate a microwave for about 45 minutes. So my e-bike battery, which roughly is that amount of power, can operate my microwave for about 45 minutes. For a house, you need a much bigger battery. Understanding this, we have to understand that we have a yearly consumption of our house. And the consumption of right now is not necessarily what you're going to need later on. You may need much higher consumption. For example, if your family grows, if you want to put tenants in the basement, if you want to connect 1 or 2 electric cars, change your house furnace to heat pump or hybrid heat pump. It's all changes of energy consumption. So the power comes to us using the grid. The grid as a production plant. In Ontario, it's mostly nuclear and hydro. And then you have the transmission lines and the transformers. Now, obviously, the grid itself is not 100% clean in Ontario. And I have the next lecture after this is about sustainability. But just that we understand what we're doing here in Ontario and in Canada in general, and I'll touch United States as well. We use nuclear and hydro in Ontario. We supplement the peak of the consumption, supplement it with gas. So that is one of the reasons the government want to give incentives to not use the electricity on peak. So the suppliers of electricity give you different tariffs, and the government sponsors things like heat pumps and solar. So we want to eliminate burning natural gas. In some places in Canada, we also burn oil. In the United States, a lot of coal, and that's not good for the environment, definitely. And also these are finite sources. So by adding solar to the mix, we can contribute to the reduction of energy consumption. So the grid has to supply everything in all the time, 24/7, 365. And the voltage goes to a higher voltage, transmitted through those huge poles that you see. Usually the voltages are in the millions of volts. That's a lot of pressure. But guess what? Less current. So the wires can be thinner, and then you don't have to use a lot of copper, which is expensive. And then it goes to an intermediate voltage, and then to your house with the small transformers you sometimes see on posts or in the boxes near your house. Now, the connection type, I'm telling you this because you need to know it when I'm going to talk about optimization. You have these plugs you see here, the 120 volts. You have the 220 volts for high power things like your dryer and your stove. And in some rare cases in houses, but usually in the industry, you have three-phase, which are different connectors like what you see here. The three-phase connector is usually meant for very big loads. So if you live on a farm, you may have that. Or if you live in a huge house, maybe they connected you, but most likely that you just get a bit bigger amperage for your house. So most Canadian houses use 240 and 120, same as houses in North America. Now, our goal is to reduce our consumption because of few reasons. First, it's very economically viable. I mean, you can definitely make money because if you put a solar system on your roof and after 6-7 years, it pays for itself by not paying electricity bills, and you have another 20 years of service, you actually have free electricity for 20 years. It's also extremely good for the environment and for the infrastructure. And especially if you had a small battery, it's going to be even better, but that's a different topic. So we have a few types of solar systems. Grid-tied. So what do I mean by grid-tied system? Grid-tied systems are connected continuously to the grid, like the one on my house, and it exports extra electricity to the grid up to a certain level. I can export up to 10 kilowatt of power to the grid. So let's say in a sunny day, my solar system can make 85 to 90 kilowatt hours, which is roughly 60, 70 kilowatt hour more than I need. I give it to the grid. Basically, the meter goes one way to consume, another way to go back, if you want to imagine it like this. So the company I'm with registers that and pays it back to me, not by money, but giving me electricity, like basically a stash of kilowatt hours. It's great, and it's very efficient in 95%, if not more, of cities and locations over Ontario, because we've got net metering as the current law. A system like this has a photovoltaic array. We have an inverter, which inverts it to AC, a distribution panel, and then it goes either to your house or it goes to the grid to be stored. In those systems, in all the systems basically, but you may also see different solutions, and they all relate to how the sun affects your system. So what you see on the right is very rare to see on a house or in a farm. Very expensive system that controls, that's an illustration, but that controls the angle of what you get from the sun, like a sunflower. Most houses have arrays on the roof. And then we can have things that are called optimizers or microinverters. This is an optimizer system. So the inverter is connected to small units that make the power usage from the panel maximized. And the illumination is also very important because we have to understand that, I have the one-on-one video for you to watch before this lecture to understand. We have to optimize the way the solar panels are located and angled too, because we want them to face optimally south, or in some cases east-west in a dual situation. And we try to angle them around 45 degrees, but in the summer it's a bit less, in the winter it's a bit more. So anything between 20 to 45 degrees considered to be close enough to optimal. As you can see in this roof, you have an angle, and this roof, as far as I can understand, faces south. So this is a very optimized situation. So the azimuth and the inclination, so where it faces relatively to the directions, north, east, west, and south. So south or east, west is good. North is never good. And then you can also connect different style of systems. You can have optimizers on each solar panel or a group of them, microinverters that replace the main inverter, or sun followers. And this is all covered in the one-on-one lecture. So the micro inverters are having basically it's a small unit like the big inverter you've seen before, and you don't need a big inverter. Each one is connected to 1, 2, or 4 solar panels. And it's basically a small inverter. There's a lot of advantages about this because if one of them fails, they still get a lot of production. They're optimizing the power from the solar panels called MPPT. They follow basically the current and voltage to optimize what you produce. And it's also has some protections and monitoring capabilities. So if one solar panel is not producing enough or fails, you would notice. And if there is a short or short to ground called the ground fault, the optimizer is going to shut down that panel. So microinverters work like this. Optimizers are almost the same as microinverters, and they just create a DC to DC inversion. So it's optimizing the current and voltage from the solar panel so you can get a lot of energy. And they also have the same monitoring and fault capabilities, but you need a central inverter. That's a system I have in my roof from SolarEdge. It's an amazing system. It's a bit more expensive. So basically choosing between string inverters, as you can see in a simple way, just a string inverter like that, or choosing optimizers and an inverter, or choosing microinverters. They're all options. And I'm telling you this because the next part is going to be explaining to you how do we optimize the system. So this kind of 3 different ways are very common. There's another one, which is solar follower. And that is a beautiful illustration of solar follower. And as you can see, the sun reflects it because it actually follows like a sunflower. Now, it's a very huge system, very big system. It's huge, expensive, computerized, usually not used in regular scenarios. I would say if you have a telescope on a mountain, yeah, maybe they use those. But for regular situations, it's very expensive. Another thing when you optimize a system is your array. And a lot of people ask me when I try to explain to them, what should I do with my roof? I don't know what to do. And I said, okay, we have to look at your roof. That's why the engineering is not immediate. It's not straightforward. We have to do a lot of understanding of what's going on. So the idea is the roof size is definitely the first parameter, and the structure has to be strong enough, and azimuth and inclination. So where is it facing and what's the angle? Now, the thing we have to also look at is the maximum limit of what we can export to the grid, and I'm going to talk about in a minute. Seasonal consumption and future changes. For example, in this case, this roof, I would put it like that. The lower one is fully optimized. I would just push them a little bit down. The upper roof, I would push those solar panels down and have another space for another set of solar panels on top. So that's a not 100% optimized roof, even though it's quite good. Now, what we usually do in northern latitude, like Ontario, and most of Canada and northern United States, we oversize the solar panel array. So that's another thing to consider. Why? Because if you have less sun and you oversize your system, you may get a few hours a day of clipping, as you can see here, because your inverter is going to say, okay, enough. The solar panels give me more than 10 kilowatts, but I don't need it. I'll clip it. But the rest of the days, you can see about 80% of the time or 70%, you actually need those panels to produce more energy because the sun is not that strong. So if you live in Nevada or Arizona or any desert area, maybe you need a smaller system. But in Ontario, oversizing, and that is something that I've seen a lot of designs that people just simply forget about it. And then they put a 10 kilowatt array with a 10 kilowatt inverter system, and then the customer actually loses money. Another thing which will surprise you, the solar panels are not that expensive. So adding 20 to 30% on that is not very, it's not very problematic. And definitely you can do this. It's very easy to do. It's not expensive, and the installation is not much more difficult. Now, you can see how clouds also affect sunny, cloudy, or a choppy day, meaning like only for a split second the sun was up here, the rest of the day was very cloudy. And another thing which is very critical is that you may have disruptions during the day. Now, this clipping probably would go up to here. But because my array, this is for my own system that I designed on my roof, I produce a lot of electricity, a lot. Actually, I'm considering to change my furnace to heat pump because I have so much electricity, and I'm going to buy an electric car. So when I do that, I'll probably be, my design is going to be optimal for me because I designed it on purpose with extra capability. Here is the solar eclipse we just had not too long ago. Look what happened. It actually follows the eclipse. You can see, so just for giggles, you can see that my solar monitoring system caught the solar eclipse, and it was interesting. And a full sunny day, you can see it was basically flat like that. So it's very, very much how you do that oversizing. Now, we understand those things. We can hopefully talk about the optimization itself. So when I'm going to talk about, I'm going to mostly focus on grid tie systems because that's not really the same situation for other people that have boats or RVs or off-grid cabins, or maybe they have a hybrid system. I'm talking mostly about, right now in that phase, mostly about how to optimize a grid tie system, but I'm going to touch base on the other ones as well. So we need to know where you are. We need to know what is your consumption and what's your future plans. Now, in this case, we talk to you, and there are a few phases, and the first page of the website can show you how we do that. We would design a solar system that fits you. And we are going to talk about this with you and expose the cost of everything and give you options. And we have to select, for example, do you want microinverters? Do you want string inverters? Do you want optimizers? And we're going to design this according to your needs, location, consumption, future consumption. Otherwise, you may encounter later on in the future issues if you want to change the system. So the grid tie system, we have to figure out what's your maximum export. And that's important. Now, there are a few ways to deal with maximum export. You can actually have even a bigger inverter and have some sensors. But from what I see on the market, the inverters are so sophisticated right now that even a regular 10 kilowatt, 12 kilowatt inverter can do the job. And we're going to discuss with you different options with your grid. And the problem we have is that we need to know what you export as well. So the moment you give us your electrical hydro company name and location, we can figure it out. So we have to discuss with you a few ingredients. Firstly, if you have a roof, we're going to show you a few options and tell you what we can do with your roof. Maybe it's an aesthetic thing. We have to know the size of array that you want to put. We're going to give you the oversizing options. And we're also going to discuss the inverters and the panels with you. So the solar panels have different price brackets. Some of them are coming with 15 years, 20, 25, even 30 years warranties, different looks. Some of them are pitch black, some are not. The technology of the inverter, we're going to discuss this with you and make sure we can optimize the system with you. Future options are also important. We're going to discuss if you'll need maybe bigger array. So in this case, you can see on the roof here, that design leaves you another maybe 30% more, and but there's more space on top. So if you tell me that you intend to double your consumption, I'm going to design the solar panels on one part of your roof, leaving aesthetically a space below and above to add more panels. And by the way, the aesthetics is very important for most people. You see, this roof is much more aesthetically appealing than this roof. Depends on your needs, okay? I didn't have enough money when I did my system. I was stressed a little bit with money, so I did not use the most beautiful solar panels. But for me, it doesn't matter. I don't mind. I also grow vegetables in my backyard, and I don't have grass. But some people really have issues with aesthetics, so we take this into consideration. And the microinverters versus optimizers versus no optimization is definitely going to be discussed with you as well, because they're different prices. I would go with microinverters or optimizers by default, but some customers have different needs, different wishes, so we listen to you. Also, future needs, as I mentioned, can include a heat pump or an electric car. The idea is that you're going to tell me if you're going to use them in the future, and we're going to tailor the system to your needs. Last but not least, backup batteries. Some people want a backup battery for outages, and I know if you live in the middle of the GTA, maybe you think, okay, when? It happened here, we had 3 days outage, but other places in Canada are not as lucky. I have friends in a bit rural Canada, and they got lots of blackouts where there's a big storm. By the way, it can happen in the summer too, but mostly in the winter. I've got a friend with a cottage near the Lake of Bays, and they got outages sometimes. So you can ask me for battery systems, and I can definitely recommend. They're a bit expensive, but they're not as expensive as they used to be. So that's another optimization we have to figure out. So most people are going to be talking about grid tie. Some people are going to speak about off-grid solutions. So off-grid meaning there is no grid. As you can see in this image, there is no grid. So it's only the photovoltaic, the solar array. Could be wind turbines. I'm not covering everything because it's too much. Definitely wind turbines and also water turbines if you've got a river near your house. But it's mostly solar. Most people do mostly solar. There's a huge battery. And what happens, you don't have the grid to store the energy. If you remember, you've got power when you consume or produce, but you have to store it. That's called energy. So that energy is stored in a battery, which you can use at night or in their clouds. The bigger the battery, the more robust the system is. So the consideration we spoke about before are exactly the same. So I'm not going to repeat them. If you jumped into this, you have to go and see the first grid tie explanation. But usually on off-grid, we have bigger arrays because you want to make sure, even on a cloudy day. By the way, solar works on a cloudy day unless it's completely pitch dark. It's very rare. Even if you see the previous slide, the solar eclipse, most of the time I could actually have production. So some people add a turbine, wind turbine, and of course a big battery to store the energy. Now, if this is your main residence, we do recommend to put a small emergency generator because you don't want to freeze to death if there's a huge storm in the winter and there's snow over your panels and there's no way you can clean them. So it's always a good idea. But with big enough battery, you probably will not touch this generator, especially, unfortunately, with climate change. We barely see more than a few days of snow on solar panels. Last winter, I barely had no production. I had production that interrupted only 2-3 days. That's it. The rest was always producing days. So you can see a cottage isolated from the environment. There is no power grid here, standalone system. So you need to talk about the batteries. Now, if this is a mobile system, which is a boat house, like here, people live on this, or a speedboat, or anything like this, or an RV, you have the same consideration, but also you have to really speak about waterproof and rigidity and being lightweight. Now, where we can do this. We have a lot of experts in this field, and I know most of the considerations myself when I design a system. And if I need to get information about the latest technology, it's very easy for me. And when you're going to ask me to design a system for an isolated location or a complete movable device like a boat or an RV, the considerations are the same, but you have to add, again, lightweight, waterproofing, and rigidity. The last systems are hybrid, and here I'm going to cut it a bit shorter. Hybrids do have connection to the grid, but they can also go zero export and not export anything, or they can go standalone. So by the flip of a switch, or sometimes automatically, you can choose what to do. For instance, the system you can maybe say, okay, in the summertime, I want to be disconnected for the grid. I don't want to pay the monthly fee for connection for anything, or maybe you're using it seasonally, and then you decide to move in. So this hybrid system can be functioning both as off-grid a grid-tie system. So I have nothing to explain much more because all the explanations before are connected to it. But hybrid solar system have both worlds. In my house, basically, I have that kind of a system because I'm using my house also as a test platform for things that I install. So I can switch my house to be grid tie or completely off grid if I want to. I just need to put a special inverter on, and that's it. So the idea is that hybrid systems are quite rare. They're usually considerations are the battery size. So an off-grid system will have a huge battery if it's stationary, and a smaller battery if it's movable because the weight is an issue. A hybrid system, it depends on the application. So the idea is to optimize everything for you. And to do this, we need to talk. So to do this, we need to talk with you and to understand what are your needs and what is your location, where you have to put stuff, what type of solar panels you need, what type of technology. And it's all about your preferences. And I will be very transparent about things, and you'll never get disappointed. Everything is going to be perfectly matching your needs. So I hope you enjoyed this lecture. I know it was a bit longer because this is more technical lecture. If you have any more questions, feel free to call me. My details are on the website. Again, my name is Gal Messinger, and I'm the owner of Solar Messenger. Thank you very much for watching the video. Bye-bye.